Good morning, everyone. Thanks for joining us for this webinar. This is actually the third in a trio in which we're looking to celebrate some of our collaborations with industry. And today we'll be hearing directly from two of those businesses that we've been supporting to improve existing products or processes. For those of you that don't know, I'll be introducing the speakers, but before we do that, just like to say a little bit about Specific. We're a UK National Innovation and Knowledge Centre, led by Swansea University, with strategic industrial partners Tata Steel and AkzoNobel, NSG Pilkington as well, and then there's more than 50 other partners from academia and industry. We have a vision to transform the world of energy by creating active buildings, and they can generate, store and release solar energy. It's the only UK centre that is developing building integrated solutions combining solar thermal and heat storage with photovoltaics and electrical storage. Specific and its partners support the commercialisation of disruptive technologies by taking the concept from research all the way through to full-scale demonstration. Obviously, we're government funded, and our aim is to promote regional and UK development, and we're funded by EPSRC and ERDF through the Welsh Government. So that's enough about us. I'd just like to start by introducing the speakers. We have two companies with us today that we've helped test and improve smart sockets from Measurable.energy, and how we plan to work with CarbonTRACK's intelligent energy monitoring systems. So from CarbonTRACK, we have Darren Shippard and Tom Bailey, who are just opening up their cameras. And these guys will be followed by Josh Eady from Measurable. So the format of the talk is we have 10-minute presentations from CarbonTRACK, from Measurable initially. And then we will have another 10-minute talk from Darren and Tom, and then an opportunity for some questions. If you have any questions, please can you use the Q&A option. That helps us manage the questions. You may have noticed the session is being recorded, and we'll also circulate any Q&A options along with the recording for those who can't attend. So without further ado, shall we kick off with Josh from Measurable?
Cheers, Justin. Hi everyone. Can you see my screen? Perfect. Okay. Hi everyone. I'm Josh. I'm the CTO and co-founder of Measurable.energy. I'm going to talk a little bit about the company and what it is we do, and then a little bit about our collaboration with the Specific project. So let's dive right into it. So. Commercial buildings have a big problem, and that problem is small power. And so small power has two key issues. The first, which is the most obvious, is that small power is not small anymore. So small power is basically defined as anything that's plugged into a building via a socket or a fuse spur. So that's not your HVAC or your lighting or your sort of big plant loads. That's the small stuff that gets plugged in. Now, historically, it's always been called small power because it was quite small, but it now represents 40% of a commercial building's energy footprint, which is actually a shocking amount of energy. And the more shocking statistic about that is that 50% of that can be defined as wasted energy. So that leads us to the second problem that this has, which is that it's entirely unregulated. So unlike HVAC and lighting, which are moving into smarter and smarter systems, which is great, small power is being left behind as this totally unregulated and unmanaged wasted form of energy. So culturally speaking, if we see a socket in the wall, we feel, that's access to free power, I'll just plug my thing in and that'll be that. And then usually because we're not the ones paying for it, we're not the ones really invested in being efficient with our use of small power. So we at Measurable.energy have tried to tackle this problem. So we created the ME platform. The ME platform is a machine learning platform designed to identify and automatically eliminate wasted energy, costs, and greenhouse gas emissions from your small power infrastructure. So to do that, we've created a system that is both hard and software. So on the hardware side, we created the ME power socket. I don't know if you can see me, but I'm holding one up now. It's a like-for-like replacement to all of the sockets in your building. So we go in and we replace all of them with our versions. They are just plug and play. A standard electrician can install them. But our sockets, they have Wi-Fi, accurate data management, so they can monitor power. We monitor 12 different variables of power 3 times a second, which is incredibly frequent. We can turn each side of the socket on and off at will. And we have an LED impact indicator on the front. I'll get back to that in a second. So on the software side, we have the user interface. So we have an app which allows you to do user registration that can register either yourself, your desk, your office, your team, your building to a certain set of sockets within the fleet of a building. And we also have the API, which lets our entire system connect with data points from other companies, other data sources, other BMSs you have in the building, etc. And we can use that data. All this data floods directly into the ME cloud, which is the real heart of the system. So inside the ME cloud, where we're gathering all of this data, we run our machine learning analytics, and this allows us to determine exactly what is plugged in, where, anywhere in your building. So, for example, we can say, okay, that's a monitor and a PC plugged into that desk. That's fine, and allows you to just monitor all your assets in real time. So where it becomes interesting is where we start to think about how and where we define waste. So we learn the pattern of a building over a course of days and weeks, and then we can say, for example, with context clues. So for example, a heater that's plugged in under someone's desk in winter at 2 p.m, totally normal, that's fine. But a heater plugged into a closet, like in the middle of July at 1 a.m, contextually speaking, it's wasted energy, so we can turn it off. That's obviously a crazy example, but that's the kind of thing we have actually seen in some of our pilots, where these kind of wasted loads or phantom loads are just left on. There's no way of detecting where they are or what they are. So the analogy we like to use is when you have you get your smart meter for your house and you plug it in, and you can see something's on, and you don't know what it is, and you can't figure out where it is. So you wander around the house holding it, desperately unplugging things, trying to work out where this phantom load has gone. With our system, of course, we can tell you exactly where everything is and how much energy it's using. You can even generate a heat map of exactly where this waste is. So the question is, now we've identified all of what's going on, what do we do with it? So this is what happens with the ME system when it's applied at scale. So the graph you can see here is for a 2,000 occupant building. So once you install the ME system, once we've identified this wasted energy, we can do 2 things with it. The first is obviously just turn it off, which can all be centrally managed, so any ideas you have about turning off energy can be implemented now automatically without any manpower. So for example, a great example we have is the hot water taps that people have in their offices, which take a couple of hours sometimes to warm up. People just leave them on because they're not going to come in 2 hours earlier to heat them up. So with our system, we can turn it on at 4 a.m. for you, no worries. It doesn't cost you anything to do that, so simple. But we can turn off this wasted energy, so this is mainly evenings and weekends, but we can also nudge people to turn off wasted energy as well. Because all the sockets are registered to people, if you leave your desk, for example, to pop out for lunch, we can simply say, oh, by the way, did you know your desk is still burning 30 watts and you're obviously not there anymore? Would you like us to turn it off? And then we turn it off for you automatically. And this process just gets smarter and smarter over time, detecting more and more waste. The second thing we can do, which is what we call the ME virtual load, which is the sort of other bastion of cost saving and revenue generating element of the ME system, is a DSR system, so demand side response system. For those of you that may not be aware, demand side response is balancing the UK grid by turning on and off large loads dynamically to help either increase how much energy we're using to match demand, or decrease, which is the more common variety. So usually these DSR aggregators target large loads like huge cooling systems or refrigeration systems. They don't usually target small loads because it's not really worth it. One light is not going to make a difference. But if you aggregate all of our loads together, suddenly we have a useful proposition. So for example, if across 10 buildings, if we have 1,000 refrigerators, all of those together suddenly become an attractive load to offer up to DSR, and they pay above the odds to allow you to control those. So you can turn off a fridge for about 10 minutes with no problems. And that's the kind of thing that DSR are really looking for. And it's very valuable to us and to them as well. And we can pass those on to the customer. We can also estimate in 2,000 person building about 5K reduction in manual reporting and error checking. So any reports you write, any data you have to go gather using your small power system is now done automatically by us, which is really exciting and really easy as well, rather than having to just get your bill at the end of the month and go, okay, I guess that's what happened, and then chuck it in. So using our system, we estimate you can get a payback within roughly 2 years. It could sometimes be less depending on the amount of DSR you offer up to the system. So that's the offering we bring to the commercial small power sector. So moving on to specific projects at ME. So we are still a young company, and so we're still developing our system. So we're running pilots at the moment. We're running pilots in about 22, 23 locations across the country. Specific have been basically, there's no doubt, have been our best pilot customers. Usually our pilot customers are what we call sort of dumb customers. So someone interested party will engage with us and we'll put them in. People don't really understand what they're doing, but they're these sockets that are doing something. But with Specific, it was a really active project. So they gave us 3 key elements of feedback, really. So data acquisition, of course, data is what we live and breathe. We need it for our machine learning. We need to understand things better. So we gave them 10 ME power sockets, which were deployed into home office setups, because obviously COVID is kind of crushing the commercial market at the moment. This helps, qualify our machine learning systems. And then we did data verification as well. So thanks to the efforts of Tom specifically at Specific, we were able to tune our hardware into a significantly more accurate sort of level over, and we did that all over Wi-Fi as well, which was really awesome for us. And it's a great offer that we can make going forward, and to have it ratified by someone like Specific is really brilliant. And obviously that sort of working together with academic institutions is something we hold dear to our hearts as well. Stan and I, the co-founders, come from an academic background. And then the Wi-Fi enterprise network testing. So because obviously these home network setups we've had to be going into for COVID, we're trying to transition into more enterprise-based Wi-Fi, and Specific have some great guys there who've been really helping us out in a really, really quite intense way to bring our product into an enterprise Wi-Fi solution, which we have now deployed as a result directly of that into other pilot customers who have enterprise Wi-Fi setups. So the measured outcomes we have, so over the course of a 3-month trial, we measured approximately 1,000 kilowatt hours just from small power loads across these home offices. That's 209 million data points, just to give you an example of the sort of scale of data we're doing. And we scaled that back somewhat as well. So we really gather a huge volume of data. And the graph you can see on the screen at the moment is just a nice visual representation of the kind of unique data quality we're getting. So that is 10 individual sockets over the course of about a month. You can see there the real spikes there generated by some sort of heater, I think that was, which is obviously the culprit of the largest amount of energy use. You can see patterns beginning to develop there as well. And of course we can zoom right into that data down to sub-second accuracy as well, which is really useful and interesting to look at a single socket over the course of length of time, and then zoom out to see it aggregate and aggregate and aggregate to the size of a building is really exciting. So yeah, there's some great data we gather from them as well. So our next steps with Specific. So Specific obviously being, what we say, they're an active pilot customer of ours, which has been great. They've got so many ideas and integrations with other companies to help us improve our methods and data. Obviously our goal as a company, we are driven by environmental sustainability. That's in our bylaws, something we're really interested in, and Specific obviously share that. And it's great for collaboration on our part. And yeah, they've been great and very proactive in pushing forward some future working together. So yeah, we see everything as a win-win here, which is brilliant. So yeah, that's me. Any questions? My details are there, but stick them in the Q&A, and that will be I'll be happy to answer any questions you have. Thanks very much.
Thanks, Josh. As I said, there are some questions coming in. We'll pick those up at the end. So without further ado, I'd like to introduce Darren and Tom from CarbonTRACK. Thank you very much, Darren.
Morning, everyone. I'm here to talk about the collaboration between CarbonTRACK and Specific. We are focusing on the area of energy trading, and the project we're working on could have quite significant implications for the direction the UK is taking towards achieving its decarbonisation targets. So that's the overall aim of our project, is to support the government's ambition for decarbonisation, which everybody knows, I think, is set at 2050, but organisations have much more ambitious targets, some around 2030 or 2035, and that's not too far away. And there are some challenges, significant challenges that we need to overcome. One of the solutions to solving those challenges is to embrace and accelerate the transition to smart energy, and in particular the creation of prosumers, and that is consumers that also produce energy. So consumers that may have a battery, a solar panel, other generation means that can produce energy to meet their own resilience, meet their own requirements, but also put energy back into the to the whole system, and that can have a significant benefit on decreasing infrastructure investment costs for the suppliers. And what we can do by creating lots and lots of prosumers is provide benefit to all in terms of lower costs of energy, not just to businesses and government, but also to householders. And we are in particular looking to work with government as leaders to deploy innovations which can be adopted by the broader community. To kick off the process of putting together an efficient decarbonisation path, we put together a model called Pathfinder in conjunction with Wales and West Utilities, and that provides an hour-by-hour forecast to decarbonisation, which basically starts from point one. If you were to turn off all of your fossil fuel sources today and operate purely on renewable energy, you would see a lot of power failures and significant gaps which need to be filled by either battery, adding solar, or converting natural gas to other clean gas sources. So this is a very complex model, a complex spreadsheet, which is being put together, as I said, in conjunction with Wales and West Utilities, around 150,000 data point inputs. And we are testing this at Swansea University. Tom is leading that project. Perhaps, Tom, you could just give the highlights of what we're doing with Swansea.
Yeah, sure. Thanks, Darren. Good morning, everyone. So I guess the question is, what is Pathfinder? So Net Zero Pathfinder is a working model, as Darren says, which creates a whole systems approach, accelerating our transition to a net zero future. It will define a clear path forward and also create multiple what-if scenarios that can be considered to achieve net zero 2050. So right now it incorporates and analyzes the current and future electricity and power network, the gas and heat demand, as well as transport emissions. But I think as we all know, the cost and practicality of decarbonising the grid and the electrification of gas systems are being extensively challenged right now in the UK, and organisations as well as the wider UK need to consider all options, I guess, to achieve that low carbon future. But the big question really is, how do we do it? So at CarbonTRACK, we have developed the Pathfinder model from a whole systems approach to a more granular adapted scenario by way of looking at an individual organisation's supply versus demand and the generation assets that they would require to create that true low carbon or net zero future. So the 2050 Energy Pathfinder enables solutions to be tested for feasibility in the real world at both organisation level and across the wider UK energy network.
Great, thanks, Tom. And part of filling those gaps to decarbonisation is, as we said, creating more prosumers. And this is where working with Swansea University is such an important collaboration, as Swansea have been a leader in the area of prosumers. An example, perfect example, is the active building set up there with the active office and the active classroom, which have solar and battery, and produces around 1.5 times more capacity than it uses. And that equates to over 5 megawatt hours per year of surplus energy, which can then be put back into the whole energy system. And that's the next part of our project, is to basically connect prosumers into the whole energy system. And the way we do that is through a smart gateway technology, which connects to individual generation and storage assets on the building site. And then in the whole system, it connects to the various energy suppliers out there, which are looking to buy that energy to solve grid constraints. The CarbonTRACK platform, as I said, centers around the gateway, which shown on the left there is that black box, which is installed currently in the active classroom. And that connects via Internet of Things wireless connection to the various generation and storage assets. And in conjunction with that, the asset owner has the power to control those assets. For example, there's a green circuit whereby certain assets will only operate if there's solar energy or battery energy available. So that's, if you like, a hard cutover to fully decarbonized operation by activating the green circuit. There are many markets to trade into since deregulation in the UK. There's a lot of new players, a lot of innovative business models and ways of selling and buying energy and commercial models associated with that. And it's very confusing as an asset owner, where to trade into, how to trade into, how much money you can earn. And so we are actively trying to make that process simpler for asset owners. And we're doing that on a project called Bank Energy, which is a Innovate UK funded project. It's a consortium of companies. It's received around £500,000 worth of funding from Innovate UK as part of the Smart Local Energy Systems program. And the specific building, the active building, is a key participant in that to help us take design input and trial the first version of that platform. And the overall aim, as we said, is to really enable the mass uptake of energy trading. So creating lots of prosumers. We want lots of those prosumers trading. We want to simplify the path to trading, and we want to make a significant contribution to the whole system towards decarbonisation, but also to reduce the cost of infrastructure for suppliers. Thank you very much. Take any questions.
Thanks, Darren. If you'd like to unshare your screen, and then if the panelists turn on your cameras, people can then see the faces and the whites of people's eyes as they answer the questions. We do have a few questions in the Q&A, so thanks for that. The first one is for measurable, for Josh. What frequency do the sockets function at?
So the sockets, they measure the 12 variables of power 3 times a second. It's 3 hertz. The reporting, when they report back to the central cloud, that happens approximately once every 5 seconds. But we do vary that depending on the context in which they've been deployed in to save the actual power use of the socket itself. So there can actually be a real-time system if necessary. We can dial that back to suit the needs of the user. That's all variable.
Cool, thank you. Next question then is, after the measurable pilots are completed, how can someone get hold of the sockets?
So we're actually just beginning to run our first sort of high-level manufacturing run. So watch this space. But we still are looking for pilots. We're looking for all kinds of contexts at the moment. So we're spreading the net nice and wide because we want to hit every kind of building going. So if you're still interested in a pilot, by all means get in touch, and we can talk about doing a small-scale pilot still. So we still are running those, and we'll continue to run them probably for at least another year or so. But in terms of the commercial offering we have, please get in touch, and we can put you on the wait list we have for basically purchasing an M&E system. Yeah.
It's nice that you have a wait list already. That's good. I think you've answered this already, but it's with, does the platform deliver in real time?
Yeah. So you can see real time. Well, within 5 seconds, which I would say is probably real time. Yeah, but yes, it is a real time platform.
Okay, thank you very much. I think the questions move over to Tom and the Bank Energy and the CarbonTRACK team then. The Pathfinder sounds interesting. How do you see it benefiting individual businesses?
Pathfinder, yeah. So
Yeah,
I guess for an individual organization or a business, Pathfinder is the more educated approach to becoming net zero or decarbonizing. So, you know, lots of businesses or organizations just think they can put solar or battery within their business and it will help them become net zero. But what Pathfinder really looks at is about the true nature between supply and demand, and that's what we've done with the more adapted scenario and granular approach to net zero. So it will provide a more educated and informed decision making to becoming net zero.
yeah. I think sometimes people don't realize it's not just the amount of energy you consume; it's when you consume that energy that's almost as important. So yeah, thank you for that. Oh, when will the CarbonTRACK platform be ready? Are you deploying it now?
Yeah, the CarbonTRACK platform in itself is something which has been deployed over 8,000 sites globally. The innovation on top of that is the energy trading part, and that platform will be delivered by Bank Energy. So it will be called a Bank Energy platform, which brings all the pieces of the consortium together in one location. And we are currently trialing that at London South Bank University, Swansea University, a council in Wales, and Hounslow Council. And we would expect those trials to be complete by November, and launching in January 2022.
So not that long to wait then, which is good.
Pressure is on.
Sounds like somebody from a residential application. If I have a battery and solar panels, how would I sign up? And is that part of your goals?
Yeah, for residential, first of all, there are different levels of the system. So as a residential owner of a battery and a solar panel, you can buy a CarbonTRACK unit and optimize your home as a standalone system. So choose when the solar should charge the battery, choose when to use the grid at the lowest cost tariff. Then if you want to sign up on top of that for energy trading, in the first instance, our platform will be available to both commercial and estates owners. So estates which contain multiple homes. As I think Josh made the point earlier about this, you know, you need a certain scale of savings to be of interest to the whole system. So if you're on an estate with say 100 or 1,000 homes, then we would aggregate together the storage and solar assets and then offer that back into the whole system. Then I suspect the granular, smaller scale will come further down the line. But at this point, it's the commercial and large estate owners.
Yeah, sounds ideal for residential social landlords that maintain and rent their properties and also have challenging carbon reduction. Another one for CarbonTRACK. Lots of renewable energy generators, but the biggest barrier and cost involves connecting to the grid. How do you see this barrier being resolved? The final grid connection.
Yeah, I think export connections are one component of trading. I think again, Josh mentioned earlier about demand side response, which is effectively net metering, which can all be done effectively behind the meter. So there are certain trading contracts that you can bid for, which deliver a drop in consumption below your normal baseline, and you will get paid for that. So for example, there are certain forward-looking contracts where the DNO may ask you to drop your baseline by 1 megawatt next Wednesday between 4 and 6 p.m. So you can do that, you can get paid for it, and you don't need an export meter. Export connection, I should say.
I think Western Power have a number of trials looking at that kind of reduction in consumption or planned reduction. And then lastly, and that's good because I'm conscious we are running slightly over. We'll try and finish this last question. Does CarbonTRACK Platform directly integrate with the grid operator services, such as the National Grid, ESO, Demand Turn Up?
Yeah, absolutely. Yeah. So there's the national grid, and there's the local markets, regional markets through the DNOs. So the idea is of the Bank Energy and CarbonTRACK platform is to provide all of those market options to asset owners, so national and regional. The path that we're putting together to guide asset owners begins with a fit assessment. So we'll gather certain data from the site and then come back to you with a proposal of what markets we think are most relevant to your asset size, your region, and the needs of both the national and regional whole system.
That's great. Thank you very much. Unless I can't see any other questions in the Q&A. We are 3 minutes over, so we're almost on time, rounding down. So unless there's anything else, I'd like to thank our presenters today, Tom, Darren, and Josh. Thank everyone for attending, and hopefully you found it useful. And no doubt if you signed up, Ella will be in contact about where you can see the recording and the responses. In the meantime, if anyone's got any questions or any input, feel free to drop either us a line and we can pass it on. But no doubt both CarbonTRACK and Measurable have websites where you can find out more if that's of interest. So on that, without further ado, thank you very much, and feel free to sign off, and we shall see you soon. Bye.